Imagine looking up at the night sky and knowing that somewhere out there, hidden in the darkness, an entire planet is moving toward us. Not orbiting a star, not giving off any light, completely invisible to the naked eye. A world wandering through the galaxy alone. For billions of years, scientists believed every planet belonged to a solar system. Earth belongs to ours. Mars belongs to ours. Jupiter belongs to ours. But modern astronomy has revealed something extraordinary. Not every planet has a sun. Some planets have been thrown out of their home systems by violent gravitational encounters. Others may have formed on their own in the cold depths of interstellar space. These are called rogue planets. They drift silently through the darkness between the stars, without daylight, without seasons, and without a permanent home. Astronomers now believe there could be billions of rogue planets in the Milky Way alone. That means at this very moment, unseen worlds may be passing through our galaxy, hidden in the darkness. The chances of one entering our solar system are thought to be extremely low, but not zero. So what if it happened? What would our telescopes see? How would the planets react? Would Earth survive? Or would our solar system be changed forever? Join me as we explore one of the most fascinating and unsettling what-if scenarios in astronomy. When we picture a planet, we almost always imagine it orbiting a star. That's because every planet in our solar system follows a predictable path around the sun. But the universe doesn't always follow our expectations. A rogue planet is a planet that travels through space without orbiting any star. It is free-floating, moving through the galaxy under the influence of gravity alone. How does a planet become a wanderer? One possibility begins in a young planetary system. When planets form, they don't always settle into stable orbits. During the chaotic early years, giant planets can tug on smaller worlds with enormous gravitational force. Sometimes those encounters are so violent that a planet is flung completely out of its home system. Imagine a cosmic game of billiards, one powerful gravitational push, and a planet begins a journey that could last billions of years. Some rogue planets may never have had a star at all. Scientists think that under the right conditions, clouds of gas and dust might collapse directly into planet-sized objects without ever becoming full stars. If that's true, then the Milky Way may contain countless lonely worlds that have always drifted in darkness. Unlike Earth, these planets receive no warmth from a nearby sun. Many are expected to be unimaginably cold, with surface temperatures hundreds of degrees below freezing. Some may be covered in thick layers of ice. Others could hide deep underground oceans kept liquid by heat from their interiors. These hidden oceans have sparked an exciting scientific question. Could life exist on a planet with no sun? It's an idea that seems impossible at first, but nature has surprised us before. For centuries, humanity assumed planets were rare. Then we discovered thousands of exoplanets orbiting distant stars. Now, scientists suspect the galaxy may contain something even more numerous: rogue planets. Some studies suggest there could be billions of them in the Milky Way. Imagine our galaxy as a vast ocean. The stars are like islands scattered across it. Between those islands, countless unseen worlds drift through the darkness. Most of them are incredibly difficult to detect because they emit almost no light. Unlike stars, rogue planets don't shine. Unlike planets orbiting stars, they don't regularly pass in front of a bright sun where telescopes can spot them. Instead, astronomers often rely on rare events such as gravitational microlensing, where a rogue planet briefly bends the light from a distant star as it passes in front of it. For a short time, the background star appears brighter. That tiny flash can reveal the presence of an otherwise invisible world. It's like discovering a transparent fish in a dark ocean, only because it briefly disturbs the water around it. Every new detection reminds us of how much of the galaxy remains hidden from view, and it raises a chilling thought. If a rogue planet were heading toward our solar system, how much warning would we actually have? That question leads us to the next chapter. How would astronomers discover that an invisible world was approaching? Imagine it's an ordinary night at an observatory. Thousands of telescopes around the world are scanning the sky, just as they do every evening. Nothing seems unusual, until one telescope detects a tiny gravitational disturbance. At first, it's almost invisible. A distant star appears to shift ever so slightly. Most people would never notice it, but computers do. Within hours, observatories on different continents begin checking the same region of space. The strange signal is confirmed. Something massive is moving through the darkness. But there is a problem. No one can actually see it. Unlike stars, rogue planets produce almost no visible light. They don't shine. They don't leave glowing trails across the sky. They are hidden in the darkness of interstellar space. Astronomers begin using infrared telescopes, searching for the faint heat the object might still be radiating after billions of years. Days pass. Finally, a faint object appears. Its size is astonishing. Initial estimates suggest it could be several times the mass of Jupiter. News spreads quickly through the scientific community. More telescopes turn toward the mysterious visitor. Its trajectory is calculated again and again. Each calculation produces nearly the same result. The rogue planet is heading toward the solar system, not directly toward Earth, but close enough to dramatically alter the balance of gravity among the planets. The discovery would become one of the biggest scientific stories in human history. Governments would demand answers. News organizations would interrupt regular programming. Social media would explode with theories, speculation, and misinformation. Around the world, millions of people would ask the same question. What happens next? Long before the rogue planet reaches Earth, the outer solar system begins to respond. The first to experience its influence would likely be distant icy objects in the Oort cloud, a vast shell of frozen bodies thought to surround the solar system. The rogue planet's gravity could disturb some of these ancient objects, sending a number of them inward. Over time, astronomers might notice an increase in long-period comets entering the inner solar system. While a single comet isn't unusual, a noticeable rise in their numbers could be an important clue that something has changed far beyond Neptune. As the rogue planet continues its journey, its gravity could also affect objects in the Kuiper Belt, home to Pluto and many other icy worlds. Some objects might shift into slightly different orbits. Others could be nudged onto new paths. These changes would likely unfold over years rather than days, but they would provide scientists with valuable data about the visitor's mass and trajectory. Eventually, the rogue planet would approach the region of the giant planets. Jupiter, Saturn, Uranus, and Neptune all have immense gravitational influence of their own. Their interaction with the rogue planet would be a complex gravitational dance. Scientists would run countless computer simulations, trying to understand how the encounter might unfold. Would the rogue planet simply pass through? Would it be deflected? Or could it permanently reshape the architecture of the solar system? Among all the planets, Jupiter would play the biggest role. With more than twice the mass of every other planet combined, Jupiter dominates the solar system after the Sun. If a rogue planet approached, Jupiter's gravity would have a major influence on its path. In some scenarios, Jupiter could alter the rogue planet's trajectory enough to reduce its effects on the inner solar system. In others, the interaction could make the rogue planet's path even more unpredictable. The outcome would depend on many factors, including the rogue planet's mass, speed, and angle of approach. Scientists would likely model thousands, perhaps millions, of possible trajectories. Each simulation would explore a slightly different outcome. Some might show a relatively uneventful flyby. Others could predict significant changes to planetary orbits. This uncertainty is part of what makes gravitational encounters so fascinating. Even small differences at the beginning can lead to dramatically different results over time. Fortunately, the vast distances between planets mean that a direct collision would be extraordinarily unlikely. Space is unimaginably large, but gravity doesn't require contact to have an effect. Even without a collision, a close enough pass could influence the paths of planets, moons, comets, and asteroids. As scientists refine their predictions, one question would dominate public attention. Could Earth's orbit change? Earth's orbit around the Sun is remarkably stable. That stability has helped create the conditions for life over billions of years. If a rogue planet passed close enough, gravity could alter Earth's orbit to some degree. The extent of the change would depend entirely on the specifics of the encounter. A very distant pass might have little measurable effect. A closer encounter could produce more noticeable changes. For example, Earth's orbit might become slightly more elliptical, changing the amount of sunlight our planet receives during different parts of the year. Even modest changes in solar energy could influence long-term climate patterns. The Moon's orbit could also be affected, potentially changing the timing and strength of ocean tides. These effects would depend on the exact geometry of the encounter and would be studied carefully by scientists. It's important to remember that these are hypothetical scenarios. The probability of a rogue planet passing close enough to significantly disturb Earth's orbit is considered extremely low. But exploring these possibilities helps scientists better understand gravitational dynamics and the stability of planetary systems. If such an event were ever detected, researchers around the world would work together to refine predictions as new observations became available. The better we understand the visitor, the more accurately we could estimate its effects. Still, even with the best technology on Earth, one question would remain. Could humanity stop it?